Good morning, all. Welcome to today's webinar, which is on electromagnetic simulation with the power of 3D experience platform. So, my name is Varsha Babu. I'm from Beacon, Bangalore. I'm working as an application engineer for electromagnetic simulation. And today, I'll be taking you through the, overview of electromagnetic simulation portfolio, what we have to offer. And at any point, if you have any questions, any queries, you can always post it on the chat window, and we'll be answering all your queries towards the end of the session. Also, we'll be, including few poll questions in between to keep you guys engaged. So please engage and answer your poll questions. So we'll be beginning now. So today, first of all, what is 3D Experience Platform? So 3D Experience Platform is a cloud solution. Basically, it's a single platform wherein we have all different roles and applications with respect to different processes in your organization. And let us take a look at today's agenda today. So we'll be explaining the 3D Experience Platform and looking at what Electromagnetics Engineer does, what all analysis and what are the features and what is the workflow that you have to follow, and few of the applications that we'll be covering, such as antenna, circuits and PCBs, EMI and EMC, which is a major concern when we talk about as many electromagnetic as well. So let's begin by understanding what is 3D Experience Platform initially. So if you look at any company or organization, there are different teams or there are different processes that are followed, be it designing, be it validation, manufacturing, even the data management that takes place, or marketing activities that takes place. And all of this is done or managed by different teams with different team members. And all these team members or different teams require different softwares or different tools they might be using. And in order to perform or go through any project, it is very important to integrate or collaborate between different teams, be it your designers or your validation engineers. So there's a lot of data interchange or exchange. And most times there is data loss, and the collaboration itself takes a lot of time to connect with the right team, to connect with the right person, and get, if at all there are any revisions as well, again exchanging the revised files and working on the revised files, for example in your simulation, to rerun the analysis on revised files, and that's a lot of data exchange. So how does 3D experience help us manage or go through the complete product lifecycle management? That is what we'll understand here. And 3D experience helps us in such a way that, because since it has a vast range of products under its portfolio, be it for designing, be it for simulation or validation, for manufacturing, for product data management, or even your marketing related activities, we have different solutions that cater to all of these different teams and team members. Now, how is that possible is, basically this works on cloud, and there are designated roles that are available for the designated teams. For example, if you're a designer, you get roles like 3D creator, you get collaborative designer for SolidWorks. So these are called as roles, which comes with a set of applications under each of these, having all the necessary features and workflows that are required for that particular role. So that is how 3D experience works. Now, all of these roles are available even for product data management in Innovia. So you have different roles to manage your data on cloud. And the best part here is the collaboration, wherein all of the data is stored in a single user interface, basically a single platform, where different teams or team members can log in and access. So whoever are designated, I mean, any project is assigned to someone, they can log in and access the specific files that are pertaining to that specific project. So that can be done anytime, anywhere, and it can be done from any device. So this makes sure that your complete organization or your complete team gets to collaborate easily and smoothly and in a fast manner. So before we begin, today we'll be focusing on simulation, especially electromagnetic simulation. But what is simulation? What do we understand by simulation, and why do we need simulation, basically? So our main objectives why we require simulation is, one is to come to or decide on the best project or product design. That is to choose between multiple alternatives. So you will have various revisions, various alternatives to your product. But which is the most optimal or the most efficient design that you can make use of? And to perform various trade-off studies from a large pool of all these, large pool of data, basically. Another aspect is to reduce the risk of failure. So basically, here in, especially in electromagnetic simulation, you have various tests or certifications that you have to perform, and you need to clear all these, testings and all these standards that has to be cleared. So basically, this is where simulation comes into picture, wherein you can virtually test or validate your designs even before you go ahead with a prototype. And also to shorten design cycles. So one part is the collaboration that makes it much easier to collaborate between different teams, from your designer to your simulation engineer. The collaboration is much easy. And today we'll be looking at the workflow, what a designer, once the design is ready, how the validation engineer can access these data and perform analysis or simulations and run studies, and then if at all, if there are any revisions that can be done. Now, the technology what we have to offer. So we have multiple simulation products catering to different areas, that is electromagnetism, thermal, and also structural. So all this is comes under our SIMULIA portfolio. So basically, today we'll be focusing on electromagnetism. Now, before I proceed, I'll be launching a poll question, and please fill these polls. I'll give you 20 seconds. So I hope the poll question is accessible to you. If not, let me know in the chat window. So the question is, are you using any electromagnetic simulation tool as of now in your organization? If you are outsourcing it, or are you using it and then proceeding with your prototype? If not, maybe you are going ahead with conventional methods, maybe some hand calculations, or you're not at all doing it. So basically, just whatever you're following, please fill the question and let us know. I'll be closing the poll now. So almost 90% of the attendees have replied no. And there is a huge, basically, gap here, because there are a lot of ways simulation can help you speed up your design cycle, as well as, uh, validate your models even before it is ready for market. So, what does 3D experience platform offer us in terms of electromagnetics engineer? Basically, as I mentioned, because of the collaboration, there is easy access to your CAD data. So once your designer is ready with the design, he just uploads it onto the cloud platform, and the validation engineer can access this at any time. So that is one important aspect here. And another part is the version control also. So if at all he has worked on the model and then there is a revised model that he has uploaded, you can also access these revision files or data that is uploaded onto the cloud anytime. So that way the team is collaborated and it is up to date with whatever changes is being made in your project. Another important part here is the lightweight visualization of results. Basically, you can view your analyze once your simulation is run the results on the cloud anytime, anywhere, in on any device, basically using a role called 3D play, wherein it is much faster to load and you can just look at be it your antenna far fields or any plots or your electric fields, magnetic fields. All these plots can be viewed in a quick manner. The trade-off analysis also can be performed, as I mentioned, from all the different revisions or all the different versions of your file, which is the best or the most efficient design. So it's much easier to choose or come to a conclusion using all the data that is available at your end. The best part here is the electromagnetic engineer role also offers cloud computing. So with each role, you get up to 16 cores, and this can be extended up to almost to 88 cores. So that is a huge advantage here when you talking about computing resources. Now let's move on to electromagnetics engineer. Basically, why do we need electromagnetics engineer or any electromagnetic simulation for that matter? So basically, in today's world, we are very connected. We have lot of devices, or as we call it, smart products or smart devices in today's world. And everything, there's a lot of automation coming into picture nowadays, and all these are because of electronic systems or electronic components getting adopted into your system. One example is your autonomous vehicles. There are a lot of electronics that are getting incorporated into today's vehicles. Even for electric vehicles, there are a lot of electronic components, and it becomes important that they comply with all EMC norms, all the necessary EMC norms. And another part is there are also new markets that are emerging and moving into this EM market. Basically, your medical equipment, there are wearable devices, lot of wearable health monitoring devices that are being made, and also for renewable energy, your solar panels and metamaterials. And all of these, since all of these interact with human beings closely, they must comply with the Bio-EM standards. And these are basically, stringent standards and certifications that they have to comply with. And here, using electromagnetics engineer, you can actually validate these different systems virtually and make sure they clear the certifications much faster. Another challenge is the increasing product complexity. Now, if you take this example here, this is a washing machine. It's a smart washing machine, might I add, because it uses IoT to connect. And basically, whenever we say any smart device or any complex product like this, there are different systems going on board, be it the control systems or the hardware, the motor, and also the mechanical parts. And it is important, even though we are analyzing for, electromagnetic emission, we need to consider a lot of these other hardware and mechanical parts as well. And what is the product performance? We can get a detailed view or we into the working of this product virtually, as well as how much time it is going to take. For example, you can reduce the time to market by making sure that all the testings and all the validations are performed virtually and it goes smooth. And if at all, if there are any risk of failures, basically. So if at all, be it circuit, right from your circuit level to your PCB level, all your embedded systems, and even the assembly as a whole can be analyzed. And all the, if they are complying with all the standards, can be checked even before your product goes to your market. Now, basically, what exactly is the solver or the engine that electromagnetic engineer uses? Electromagnetics engineer uses the SIMULIA CST Studio Suite, which is an industry-known software or tool for electromagnetic simulation, and it has it covers a wide range of application, right from statics to low frequency to high frequency. So when I talk about high frequency, it can be antennas, it can be filters or other RF and microwave components and devices. It also helps you in addressing your EMC and EMI related challenges or issues. And one important feature here is the couple simulation, which we'll be seeing ahead in our presentation. Examples which make use of these couple simulations. So you can perform electromagnetic analysis here on your circuit level, system level, PCB level. You can even make use of multiphysics. Basically, there are thermal solvers, mechanical solvers that are available for you, which can be coupled along with your electromagnetic solvers here. So in case of any hotspots in your design, or to identify if the heat generated causes any deformations in your model, you can make use of coupled simulations here. And there is also something called as EM circuit core simulation, wherein there is a schematic level control as well as assembly level. So that can be analyzed simultaneously, both your assembly as well as schematic, by making use of various blocks, which we'll be seeing. Before that, let's see all the wide applications I mentioned. Let's see what all analysis or what all areas that it covers. So we have static and low frequency, wherein you have various EM devices for magnet design, coil design. In case of any shielding related applications, sensor design, you can make use of basically your electromagnetics engineer with CST. And for microwaves and RF, again, as I mentioned, antennas, any sort of antenna or any type of antenna can be designed and analyzed here within your CST. That is, be it your patch antenna or your horn antennas, biconical antennas, even antenna arrays, and also RCS related analysis can be performed here. And if you have any filters, these can also be analyzed here using electromagnetics rule. Now, moving on to our EDA or ECAD related. So we have, again, once your circuit analysis is done, that is also available. And then we have signal integrity, power integrity, and we have signal integrity, power integrity, co-simulation, and also to compute the losses, various losses in your, EDA designs or PCB boards that can be made use of. Under EMC and EMI, again, we have radiated emission, conducted emissions, also the immunity, the EM immunity, be it conducted or radiated. So these are various applications when we talk about EMC and EMI that CST covers. Now, we also have solvers that are designated for particle dynamics, that is charge particle dynamics, in order to design electron guns or other, vacuum electronic devices or accelerator components, basically. So basically, all of these applications are covered, as I mentioned, and this is all covered in one single user interface. So there is no need for you to, switch between different modules or different, let's say, windows here. It's all available under one single user interface. And all these applications obviously require different solvers. And basically, your electromagnetics engineer with CST has all the necessary solvers that are required to run these different types of analysis, which are shown here. Now, what is the workflow? So obviously, you need a CAD or a 3D model to start with, basically. And once that model is ready, using the 3D experience ID, the user can upload the design, basically the designer here in our case, can upload it onto the cloud. And this model can be now accessed by the validation or simulation engineer. The electromagnetics engineer can access this model and then go ahead, set up the simulation. I mean, whatever required input sources, loads can be fed in using CST, within CST. And once that is done, he'll run the local simulation and then validate or analyze the results, whatever is calculated. Now, he can also go ahead with what if scenarios, basically any revisions he wants to make, or he wants to explore other options. He can make changes to, if he wants to make or work with a different model, what he can do is the designer, he can let the designer know, the designer can make changes, and this model will again be uploaded to the cloud, and then this can be easily accessed by the simulation engineer. And that way, the collaboration here, you can see how smoothly the collaboration works. Now, we'll be covering different sets of applications here with different cases. Before that, let's just go through another poll question. So, I hope the poll question is visible to you. Basically, we're just trying to understand if at all you go through these kind of scenarios wherein you have, redesigning or reworking that happens, and lot of issues you would face collaborating with different teams, and if you face any risk at meeting, project deadlines, is that an issue? So please let us know by answering the poll. Okay, I can see most of you have answered yes, and this is exactly where our 3D experience platform can help you in, collaborating with different teams, and it will help you, you address all your project-related challenges and make sure that you are able to deliver your project at the right time. So let's move on to the various applications that we'll be covering today. So we'll be starting with antennas, and these are few applications that CST or electromagnetics engineer can help you address. The major one being, as I mentioned, in high frequency antennas, filters, microwave, component design. And then moving on to our circuits and systems, then we have on PCB level for signal integrity, power integrity, and under EMC and EMI, we have various analysis and applications that we cover. Also the bioelectromagnetics part. Then we have sensor, magnet design, and coil design, which is another application. So let's just go through them one by one. So moving on to antenna design and placement. So here what we see is a patch antenna model. Basically using CST, you can analyze any antenna model here, and you can view various results like S parameters, your VSWR plots, your radiation pattern can be observed, and also the different fields and plots. And you have excellent post-processing features here which can help you in viewing all the computed results. Now, once your antenna is designed, another important factor is the installed performance of the antenna or the placement of the antenna. So what happens when your antenna, once it's analyzed and placed within your complete system or assembly, what is the performance of that antenna? So you can also analyze these kind of scenarios here. Once your antenna is placed within the system, what is the radiation pattern? How has it varied from its initial or standalone performance? These can be analyzed here, as well as in this case, if you look, this is an antenna array wherein you can see there is a placement related analysis that we have performed, and we're trying to identify which is the most optimum location for the antenna to be placed on this particular, tower. So here, what is the radiation pattern after the antenna is placed? That also can be analyzed here. Now, Electromagnetics Engineer also comes with an antenna placement app to help you easily optimize your antenna placement and location on your systems. Let's just look at the workflow. So basically the collaborative workflow here in SolidWorks, once your patch antenna is ready, the designer is logging into his 3D experience platform and loading the file onto the 3D experience platform. Now the validation engineer can easily access this from the platform and then pull it into CST. He's setting up all the required loads, be it the ports here for the excitation, your materials can be defined here, as well as any other required inputs can be fed in. Now once the analysis is done, he can also view the results, and here we see it's around 4.7, but he's looking for something at 5 gigahertz. Now the antenna validation engineer is going to notify the designer to make necessary changes. The designer comes here, comes back to SolidWorks, makes the required changes to the design, and then again uploads the modified file onto the cloud. Now, this file can be easily accessed by our simulation engineer, and then he doesn't have to reset all the inputs or anything, because it's already set once. So he just has to fetch the file from the cloud and then rerun the analysis and view all the results and make sure if he's able to achieve the required results or not. So basically he can just rerun the analysis here, and we'll be seeing the plots, and you can see it's much better here. So it's around 4.99 gigahertz, which is close to 5 gigahertz. That's exactly what we needed here. And he'll just upload these results onto the cloud platform. Now, this results will be available in the collaborative space on cloud, and it can be accessed anytime. And using physics review app, we can easily view the results here in a much faster manner. So you can view automatically, all the plots will be uploaded, or the S parameter plots, and then also the far fields. You can view the far fields here, how the far fields are, what is the radiation pattern, and all this can be viewed on cloud. And this can be done using any device for the matter. Now, moving on to circuits and systems. Basically, we'll be focusing on co-simulation here. Now, what is co-simulation? As I mentioned, there is a feature here wherein you can link your schematic along with your 3D model. So be it antennas, what happens is the antenna model can be generated as a block. So most of you will be familiar with blocks. You have different types of blocks, right? You would have heard of spice blocks, you have ibis blocks, touchstone blocks. So something similar. CST will help you in generating custom blocks as well, other than all these standard third-party blocks. So you can make use of these blocks in your system level or assembly level analysis as well, which we'll be seeing. And as I mentioned, CST supports basically all your spice block, touchstone block, ibis models are supported here. Now, at a circuit level, we have different types of analysis also that are available. And to support this, we have a library of different circuit components that is available for you to make use of. And these are different analysis, or we call them simulation tasks in our environment. So you can perform, if at all you have interference, that is to avoid interference right from the circuit level, you have an interference task that is available for you to make use of. Or other than that, the transient analysis can be done. If harmonics related analysis can be done, eye analysis can be done. So these are different circuit level analysis that you can perform. Now moving on to what I mentioned about the block. So if you look at this figure, this is a couple microstrip. Basically, this is a 3D model. You also have the model in the form of a block, which you can make use of in your schematics. Now, this can be made use of in the circuit level analysis as well as couple it and run the 3D level analysis. So from the circuit level, you get all the different plots, be it your voltages, your currents, and in your 3D level, you can observe all the fields, all the currents, surface currents, if at all any losses are there, what are the losses. So all of this can be done simultaneously. Now moving on to system assembly and modeling. So this is an important feature that we have here in CST. So basically what it does, it acts as a tool for controlling, sequence controlling. Basically, if you want to perform multiphysics analysis, so once your antenna, let's consider this antenna itself, it's a horn antenna and there's a reflector place. But initially we are trying to analyze the antenna structure. Now once the electromagnetic analysis has been performed, you also want to perform the thermal analysis and you want to link it. So the system assembly modeler is what makes sure that the link or the integration between these projects are maintained. So it also acts as a project manager with all the thermal, as well as if you have any deformation, if you want to observe the deformation that is caused, you can also run a mechanical analysis. All these will be linked with the master project as well. So any changes you make for later on can be linked to all the sub projects, and you can rerun these thermal and mechanical analysis at any time. So this is basically what is system assembly and modeling. Now, hybrid simulation is another feature wherein, for example, if you consider this antenna will have a certain radiation pattern. Now that is falling on the reflector. But what happens once the waves or the radiation is reflected back from this reflector? How is it in turn affecting the radiation of this antenna? So this is a two-way cycle, right? So one is the radiation pattern from the antenna, which is like a unidirectional one, but it also supports the bidirectional analysis, wherein you can see what is the effect of the reflected, radiation on the radiation of the antenna. So that is another feature that we have here. And this is all controlled using the system assembly model. Basically, it's like a schematic with all your blocks. So you have your schematic level as well as in the assembly model, you have the assembly as well. Moving on to PCB analysis. So when we talk about PCBs, we'll be working with different PCB design softwares, be it Altium, be it Allegro, Metagraphics, softwares. So there are various files that CST supports. Basically, all these different files are supported by CST. You can also make use of a neutral or generic file formats such as ODB++ and import these files into CST. And also, once the model is imported, the design rule checker or the board checker basically checks for any overlaps or discontinuities in your design or in your nets. Basically, there is a design rule checker which you can make use of, and there is something called as IR drop analysis, which is nothing but the voltage drop across various components or in your design basically. And the best part here is whatever losses are computed from this IR drop analysis, this can be directly integrated with the thermal solver. So we also have a conjugate heat transfer solver wherein it is directly, linked with the electromagnetic solver, and all the losses are fed in, and you can go ahead with the thermal analysis on your PCB as well. Now let's just see the workflow for a PCB level analysis. So we'll be performing power integrity analysis here. So before that, the designer is making use of Altium to design his file. So there is an Altium connector that is available on cloud. So he just has to upload the files onto the 3D Experience platform, and these files can be directly opened within CST for the PCB level analysis. Now, here you can see the power integrity analysis that is going to be performed. So what you will do is you will be selecting all the required nets, and you will be defining all the, whether all the grounding and the power nets. And after that, selecting the power pins and running the analysis. So once the analysis is run, you can view different plots and graphs. One being your impedance plot or impedance mapping. It will, identify regions where all your impedance is high. If at all you need to add any decoupling capacitors, or if there are decoupling capacitors, if you have to change any values. Once that is done, the result is analyzed. He can just upload the results onto the cloud. So he'll just give a name and description, and just upload the simulation data onto cloud. Now this can be viewed on cloud anytime. And if at all, if any changes are required, the PCB designer might make some changes. And again, these files can be fetched from the cloud. It can be imported. You can re-import the content here and rerun the analysis. So these are different. So this is just power integrity. Similar way, signal integrity, IR drop analysis, and also we have a DDR4 wizard for any type of DDR technology. So this is our EDA related, interface or whatever features that are available within CST. Now moving on to one of the major concerns or the most important part in any electromagnetic system when we talk about the EMC and EMI. Basically, when we talk about EMC and EMI, it can be either conducted radiated emissions or the susceptibility or immunity of your system. Now, it can be at, as I mentioned, at circuit level, it can be at the PCB board level, or even the system or assembly level. And CST supports you or helps you analyzing all your, emissions and noises right from circuit to assembly level here. Now, there is also an EMC workflow that is available within CST, which can help you with the setup for various tests, and also to comply with various standards. So there are a lot of standards that you follow. So there are, by default, there are some standards that are included. And if at all you have any other standards that you work with, you can also define a user-defined standard here. You just have to upload the file with the right test conditions or the right sources and values that will be loaded, and you can perform the analysis here. So this EMC workflow makes it much easier to set up the analysis and also to analyze your results in the post-processing part. So let's just look at an example of conducted emission here. So this is basically a DC-DC converter used in an automotive vehicle. So here we are stepping down the voltage from 12 volt to 5 volt. And here if you see, we have the circuit schematic as well as the board available. So initially we'll be analyzing this circuit for any noise that is getting generated or incorporated during the switching action of the circuit. So when you run the analysis, you can observe what you can compute what is the noise that is generated in the circuit. So here if you see from the plot, you can see at around 0.48 megahertz, you get around 100 decibel microvolts. So this is the noise level that is getting incorporated in your circuit during switching. Now here, right at the design stage itself, you can decide if you want to mitigate these noise levels, you can add in filters, the required filters, you can, optimize the system at the circuit level itself. Now, once the circuit is done, your PCB is designed, then comes your 3D or PCB level emissions. So here again, we are computing the conducted emissions here under two different scenarios. So what we'll be doing is we have a filter design for the circuit. So we'll be analyzing the circuit under different conditions, such as when the filter is not activated and when the filter is activated. And from the plot, you can see without the filter, the peak, emission value is at around 94.88 decibel microvolts. And when the filter is activated, we are able to mitigate these emission levels up to 53.55. So basically, here right before your prototype is created or you're going ahead with your design or manufacturing, you can virtually make sure that all your model or your design comply with all the required EMC norms or standards. The next example that we have is of radiated emission. So here we have a case of a smartphone. So wherein, again, when we talk about EMC, shielding is a very important part, be it shielding of different electronic enclosures or shielding of even cables. And these different scenarios and applications can be analyzed here within CST using Electromagnetics Engineer. So here we have a case wherein we are analyzing for the shielding effect of the enclosure of the smartphone at two different conditions and two different frequencies. So one is at 2.5 gigahertz. What is the radiated emission when there is no shielding or when it is unshielded, and at 2.5 gigahertz when it's shielded. And from the plot you can see at 2.5 gigahertz we are able to mitigate the radiated emissions in a quite good manner. But for the same enclosure, if you measure at 7.5 gigahertz, it is as good as it is unshielded. Basically, the shielding effect is quite poor here. So from this, you can come to conclusions or decisions that you need to make any changes in your design, turn the design into a much more broadband receptive type, or if at all you need to work on the shielding or the enclosure model, change the material of the enclosure or the thickness of the enclosure. So these are important decisions that you can take right at the design stage itself, without waiting for going ahead with a prototype and then testing and then identifying these faults and failures and going back to the redesign again all over again. So that is another part. Now moving on to bio-electromagnetics, which is nothing but all your medical, life science related applications. So we have different systems, imaging system, development systems, implants, and electronics and communication. For example, your smart watches, your wearable devices, and CST can also help you in detection of cancer detection devices, etc. So these are various applications, and they have different parts or different areas that needs to be analyzed. For example, right from circuit design to then your sometimes it's coil, in case of your MRI coil design and analysis, and even the safety. That is nothing but, since these are all closely interacting with human body, what is the absorption rate or specific absorption rate, that is the radiation or power absorbed by the human body from all these different devices. So the CST also has a biomaterial library wherein it has different human body models available for you. Human body, materials like your different tissue material, bone material, different organ materials that are available for you to make use of, so that you can use them and identify or calculate the specific absorption rate and make sure that these are within the legal limits. So let's see what are the major, application area. As I mentioned, one is your imaging and diagnostic devices. Then in case of MRI coils, and also the absorption that is the human body is going to absorb when they are within the MRI coils. And also in brain cancer detection, thermal cancer treatments or ablation as we know it, and various implants that are used. So it can be a hearing aid, it can be a hip implant, your pacemakers. So to analyze under, the working of these different implants under various different conditions or scenarios. You can do all of these virtually. You can make use of the biomaterial library, pull in human models that are available, and make sure your specific absorption rate is within the legal limits. Now, moving on to sensor design. As I mentioned, CST can also help you in analyzing different types of sensors. So here you can see we have capacitive touchscreen sensors, we have inductive position sensors, be it angular or linear position sensors, and then for proximity sensors, speed sensors. There are various sensors that are there. So all of these sensors can also be analyzed virtually within CST as well. Now, these are a list of a few of our customers that we have worked with. So they are again from different, industries that we work with, and all of them have made use of CST and electromagnetics engineer in the most, efficient manner. Now, to summarize, basically, we have gone through what exactly is 3D Experience Platform, how the 3D Experience Platform on cloud can help us collaborate between different teams in our organization, even different teammates in the same team. And we have seen Electromagnetics Engineer Role, which makes use of CST Studio Suite, and all the features with respect to be it your circuit level, your assembly level, and what is the workflow that is followed once your design is ready, how it can be pulled in into CST for your electromagnetic simulation. And we've also covered different applications that CST can help you address, such as antenna design and placement, your circuit and PCB level analysis for your signal integrity, power integrity, also to compute losses, your thermal analysis that can be performed as well, and for EMI and EMC related applications to compute the emission levels, be it conducted or radiated, and also your EM immunity. Now, moving on to the bioelectromagnetics part, we saw how we can make use of the existing bio library within CST and analyze different medical equipments and different scenarios wherein these are affecting, or when humans are interacting with the systems, are they safe, and if they can meet the EMC and EMI requirements, and also different sensor related applications. I have another poll question which I would request you to take a moment and fill. So I hope the question is visible to you. So this is just to help us identify what all applications do you work with, where do you, what all analysis or applications are you looking for or you work with, and any issues related to these applications. So if you have any questions, you can, make use of the chat window to post them. So I'll be closing the poll once you have finished. So I'll give you a couple of more seconds. Okay, most of you have EMC, EMI related applications, which is obviously that is one of the most important area here. Now, I'm open to questions. If you have any questions, you can post them in the chat window, and I'll be happy to help you with those. Okay, we have a few questions and inquiries. Please do post your questions in the chat window. So Mr. Lingeshwaran has asked if we can share the information today which we have presented. We can share some details regarding, for example, the brochure as well as some other data sheets and documents for your reference, sir. Yeah, we can always reach out to you to discuss, because you did mention that you want to discuss. And we have a question from Mr. Chandravel, how to measure the magnetic field strength, basically. So it depends what system you're analyzing. So you can perform a magnetostatic or a transient analysis, and you will have all your different plots and fields, even the magnetic field strength. It can also if you perform an electrostatic or the transient analysis, you also have the electric field and flux analysis results that are available for you. So all the results will be available once the the analysis is performed. Okay, if at all anyone wants more information, you can reach out to me, and we can, conduct a detailed demonstration if you're interested at your premises, basically. Mr. Vikram has asked for reference data sheet of the tool. I believe you're talking about the brochure and all the features, and if at all any application related data sheets. Yes, sir, we can share these documents with you. So we'll be sharing it on your email, basically. You can always reach us for any enquiries. You can, reach us out at the email from which the webinar link you have received, also marketing@beacon, or you can reach out anytime for any queries. Okay, we have one question wherein the CAD file support formats is been asked. As I mentioned, along with all the various EDA file formats, various 3D CAD files are also supported, be it from Creo, be it from, SolidWorks is supported by default, and be it from Inventor or any other CAD tool, Parasolid, Autodesk related. All these file formats are supported along with neutral file formats. Okay, someone has a question whether whatever software tool we have is a subscription or term-based or a perpetual. So whatever cloud role we have is a term-based license, but we do also have the same solution, that is CST Studio Suite, as a desktop, which offers perpetual licensing as well. Okay, there's a question from Mr. Karthik, regarding demonstration. As I earlier mentioned, we can visit you, or if at all if you want to do it online, we can have an online demonstration, and you can take a look at the in detail capabilities of the tool or the software. And if you have any technical queries, also we can address those during the discussion. Okay, Sunny has a question asking what is the hardware requirement. So as I mentioned, using the electromagnetic engineer role, you get up to 16 cores with each, we can call them as license with each role. And it can be extended. You can purchase more resources up to 288 cores is what we have to offer. So along with 16 core one, you get 128 GB RAM to run all your electromagnetic related simulations. Okay, Mr. Kumar has a question. If IBIS models are supported, yes, sir, we do support IBIS models as well. If you have any more questions, please do post them in the chat window. I think, yeah, we have, if you have any more questions, you can reach us out anytime and we'll get back to you. So thank you everyone for attending today's webinar. I hope you had an insightful session today, and please get back to us if you have any queries or any requirements. Thank you.